I'd like to take a look at section 6.2, which is now we're going to look at graphs of exponential functions. So I alluded to this section at the start of chapter 6 when I said that we were going to look at graph transformations. That is our goal now, is to try to study all these types of graph transformations for our exponential functions. So for instance, if we look at f of x equals 2 to the x plus 3, what does this look like? So remember, we can start out with this graph of 2 to the x. We've seen that. So if we think about when I add 3 to the outside, what type of graph transformation is occurring? Well, this is going to be a vertical shift up 3 units. So that means we now have the graph that looks like the following. So if we think about what's happening is that every single thing is being shifted up 3 units. So that includes this axis, or this y-intercept. We saw that happened at 1. If that's being shifted up 3 units, that means that's going to happen over here at 4. So then if we ask some questions like the range and the horizontal asymptote, well, we see the same thing takes place. That the horizontal asymptote was at y equals 0, and that is now being shifted up 3 units. So we now have this horizontal asymptote at 3. So horizontal asymptote is the horizontal line y equals 3. The range, well, we said the range of this function was 0 to infinity. It was all of these positive numbers. Here, if we shift that up 3 units, well, it still goes up to infinity, but now we don't start at 0, we start at 3. So the range is now 3 to infinity. And remember, we're not including 3 because it doesn't ever actually reach this asymptote. In this case, it's just going to approach it very closely. So then in general, if we want to summarize this, so if we have this plus a number on the outside, so if I have a times b to the x plus c, the horizontal asymptote, what will that be? Well, in this case, it was y equals 0. For this, it was y equals 3. So in general, it has to do with this plus c. It is always y equals c. Remember, it is y equals because it's a horizontal line, so it's a horizontal asymptote, and it's just that number on the outside of the vertical shift. So if we take a look at some examples of now starting to combine some of these transformations, the graph of f of x equals 3 to the x is reflected over the x-axis, then shifted up 3 units. We'd like to find this information out about it. So if we think about 3 to the x, this is what we start out with. And then we apply the graph transformation of reflecting this over the x-axis. So if we think about the graph transformation that takes place, we said that reflection over the x-axis is going to have a negative appear in the front. So this becomes negative 3 to the x. Now remember, order of operations says that I have to do exponents first. This is not the same thing. This is not the same as negative 3 to the x. These are very different things. You're not raising negative 3 to the exponent. You're raising 3 to the exponent, then multiply by negative 1. So make sure you have your order of operations down. So that is our reflection over the x-axis. Now if we shift this up 3 units, well, then it's the same thing that happened over here. We add 3 to the outside. So I have negative 3 to the x plus 3. So I shift this up 3 units. And so this is my new equation. I'll call this a g of x is equal to negative 3 to the x plus 3. So that's my equation. My y-intercept, remember, to find the y-intercept, we said x equal to 0. So I can just plug x equals 0 into this. So I have my g of 0 is equal to negative 3 to the 0 plus 3. Now remember, this is where you have to be tested to see, do you remember the order of operations? I said exponent first. 3 to the 0 is 1. So I have negative 1 plus 3, which gives me 2. So my y-intercept is the point 0, 2. Because remember, intercepts are points. It has both an x and a y coordinate. The domain is all the x values I can plug in. The domain of this function is not changing with any of the transformations we do. The exponential function will always have a domain of negative infinity to infinity. Always, 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 this is the case for an exponential function. No graph transformation will change that. The range, on the other hand, this will change. Now, trying to look at the equation might get a little bit tricky. So if we think about what actually took place graphically with this, all of these transformations, if I start out with 3 to the x, it looks like this. Then if I reflect over the x-axis, well, then everything gets reflected over, and it looks like this. So this was my negative 3 to the x. Then if I shift this up 3 units, well, then this gets moved up by 3. So my asymptote gets moved up 3, and now I look like the following. So this is my negative 3 to the x plus 3. So if you notice on this case, the range is going to be going down to negative infinity. So all of our y values are negative infinity up to 3. So my range, negative infinity to 3. And my horizontal asymptote, you could see from this that it's y equals 3, or as we said, it's always this number at the end. Whatever we're adding and subtracting off at the end. So we're adding 3, so our horizontal asymptote is y is equal to 3. And so that's what it looks like to now do some graph transformations and see some of these properties and how they have changed based off of these transformations.